So there are three properties in vibration that are quite important, which is the stiffness, as you managed to talk about quite well in a good example. There's the mass, it's really important as well, and there is the damping. The damping is this. So if I shake this beam, it will eventually stop shaking, and that's because of damping. And damping is a mechanism of energy loss, and eventually energy will all be converted into heat. That's what happens. But I can't really feel the increase in heat here.
But if you did that 1,000 times, maybe you'd.
If you do it very, very quickly in materials at 20 kilohertz,
Mm.
you will see the material getting hot.
Mm.
And when the machine is on the beta version, so when it's not really working as you intend, so temperature reached that level, but the while loop continues spinning around, it didn't stop. That's why I have there an emergency button. You will see smoke coming out of the metal and turning blue, which is oxidation, like quenching, and you don't want that to happen.
I guess that makes for an unfair test then, because I suppose when materials are are hot, they respond differently to vibration.
Yes, right. Very good.
Thank you.
No, yeah, definitely. So,
yeah.
So that's why we need to. So we can actually have the downside is we need to have a range of temperature which is relatively limited, so that we don't have those differences visible. But the advantage is if we want to also test it in harsh environments at higher temperatures, we could do that as well, very easily. So, yeah, it has. So we need to cool down the specimens somehow because of what you just said. It does change the stiffness and the properties and the life, etc. The ductility.
Is that a problem? I mean, to me, I'm thinking it must be heating up just after, say, like 10 cycles or whatever, a little tiny fraction of of a degree or something. At what point does it become a problem, or is it always a problem, even at the? Do you know what I mean? It can't just go from cold to hot suddenly. It must be a
no, but we're talking about 20,000 cycles a second. It's like it's doing this 20,000 times in 1 second.
You can't even fathom that. I can't even really. But this is why we can't even see it happening.
It's really, really fast. So it's.
So what I'm saying, after 1 second, does it not heat up?
Oh yeah,
just a tiny bit. So is that a problem then for testing, because it's never truly a reliable test in that sense?
Well, it probably takes a few seconds until it reaches. Yeah, it's feasible. Yeah, it's feasible. It doesn't become a problem, no. But obviously, the higher the stress you are introducing, the quicker each sequence of testing has to be done.